Welcome back to the Contractor School. Remember to take good notes on this. We are in section for conduit fill or wiring methods and materials. So once again, conduit fill, pretty simple if you use Annex C, but using Chapter 9, Table 5, Table 4, a little bit more time consuming. So go ahead and start turning there if you could. Table 5 starts on page 684, page 684 in your code books. Let's make sure we understand how to do this. We'll at least do one example, maybe two, and then we've got to move on to some other topics. However, conduit fill is kind of a big deal in that they're throwing a lot of questions at you. Very simple, very, very simple, but we don't want to make a mistake here. There's a lot of little decimal numbers that we need to add up and not make a mistake. Get the right size wire the first time. We don't want to go back and do this math again. Do it one time, do it right, and get out of there, okay? So, conduit fill using table 5. So let's go ahead and put in our notes here a question, okay, and put some of the details here. We're going to have this time we're going to go ahead and use the schedule 40 PVC, okay, and there's multiple conductors, right? There's in this case there's going to be 5 conductors, and so let's make sure we do it right, okay? They're all insulated the same type, and so let's see now. How about we do yeah, let's go ahead and do 5 conductors. So actually let's see, let's go ahead and do one out of the lecture material here. Let's go ahead and do this one here. Calculate the minimum size schedule 40 PVC required to install 5. Well, is it really 5? Yeah, we're gonna make sure we do this math right here. We got, no, that's 4. There's 4 of them there. 4 THHN conductors, because we got 2 500 kc mills, and then we got 1 350 kc mill, and then 1 number 2. So let's do this one. I think this one makes sense to go ahead and do it this time. Okay, so calculate the minimum size schedule 40 PVC. So once again, put this in our notes. We got 4 conductors. Let's switch gears a little bit here. We got 4 conductors, and let's go ahead and put them in there. We got 2 that are 500 kc mil. Put this math down. Make sure we get this. We got 1 that's a 350 kc mil, right? And then we got 1 that's a number 2 AUG. Okay, so this really isn't difficult, just very slow. Okay, we got to use chapter 9, table 5 first. Okay, and we got to get our areas in square inches. So you should already be there by now. And we need THHN. Starts out with this RF and all this stuff in here. We never use these for the examination. So sure enough, first page won't work probably. We got to go down to THHN. I don't see it over here. It's all this other stuff. And so we got to go to the second page of table 5. And there's THW. That's not it. THHN. There it is. Okay. And we need to get various sizes from here. Now, what I'd like for you to do at the beginning of this table so that you can remember is go ahead and highlight or circle approximate area, and then also at the same time highlight this column, kind of put a box around it going down, because we always need area in square inches, never diameter and never the metrics. You see the metrics over here and the metric over here and the diameter over here. We'll never use that. We always want to use area, and we always want to use square inches. So highlight that column so you don't forget. That's always the column that we use. And since we're coming down to THHN, and the first conductor that we had was 500 kc mil, got to be down in the second section because it's so big, right? And we got to come over to 500 kc mil and follow it on over. And I see that 0.7073. Okay, so that's our important number right there. Once again, THHN. over here on the left, 500 kc meal, following over, get the 0.7073. Okay, so that's the number we need right there. Okay, so after we do that, you know, not too difficult so far, right? We go ahead and get this thing going here in terms of the math in our notepad. We got to get 2, right? Because we got 2 of them, times this number that we got from the back of the book there in the NEC, wasn't it 0.7073, right? This is our inches squared, right? The area, and then we multiply that out, right? But before we do that, let's go and put our other ones in. We got 1 times the area for the 350 kc meal. We also got 1 times the area for the number 2 hogs. Let's get those numbers first, and we'll do all of our math in there. Okay, so looking for the 350 kc meal, and some of you may already be ahead of me here. Isn't it just right here? Sure, it's right there. Not tough, not tough. Just move up a little bit. 0.5242. So in our notes, we got to write that number down. The 0.5242, 0.5242 again, inches squared. Okay, and then lastly, the number 2 og, and we'll probably have to move the picture here a little bit because 2 og is going to be up in here, right? We're still in the THHN, right? Double check we don't get this wrong. And then a number 2 and slide all the way over to here, and you see that 1158. Okay, so in this case, that's our number right there, 0.1158. So in our notepad, once again, 0.1158, right? Inches squared, write that down. And then we got to do all of our math here, right? We got to knock this thing out in terms of our math. Not tough math, just, you know, time consuming, right? So wouldn't we have 2 times 0.7073 and hit the equal sign, and we get that 1.4146. Let's go and write that in our notes. 1.4146, right? That's inches squared, of course, right? And then the next one, right? The 1 times the 0.52. Well, that's easy enough, right? We just bring our number on over, 0.5242, right? Inches squared. And then this one here, no math, right? No math involved here. Just bring on over our number, 0.1158. Now, we do need to use our calculator, or we'll mess this thing up. Note if I carry this out to the 4th digit, and I don't compromise on that, because they could make it so close in the sizing of the conduit that 3rd and 4th digit could make a big difference and make you an error. Okay, so let's go ahead and add this thing up now. It's not tough to do. It's just basic math, right? We still got our point, the 1.4146 in there, so we just need to add the others, right? So we just add our 0.5242, and we add our 0.1158, and we get 205. Okay, and so that's our total area, right? So let's just go ahead and put it this way here in our notes, right? Our total area, right? Not diameter, right? Our total area is equal to 2.0546, right? Inches squared, right? So we need that. That's step number 1, right? Let's write that down. That's step number 1. Okay. Next, we need to take this value that we got from table 5 on over to table 4, right? To size the conduit, right? So not tough to do. Just back up just a little bit in your code book, and we're going to look for schedule 40 in this case. So just slowly back up in your code book, right? Table 5 is kind of long, and then you see table 4, and it has all this stuff, right? Rigid PVC, rigid PVC type A, type EB, all this stuff. There's schedule 40, and if I back up, schedule 40, that's what I need, right? So make sure that you're in the right table, because you got Schedule 80 you got in there, you got rigid in there, you got liquid flex in there. Make sure you get to the right one. Double check, triple check, Schedule 40. Yes, I am good to go. That is the correct table. I'm on page 683 of the NEC 2017, page 683. So Schedule 40, I got the right table. Now, once again, you'll always use one column and one column only. You'll never use all this stuff over here, so don't worry about it, okay? But over 2 wires, I'd like for you to highlight right there. That's a very big deal to highlight. And then also highlight this column, right? So you always want to use, regardless of whether it's EMT, liquid flex, rigid, in this case, Schedule 40 PVC, Schedule 80 PVC, you always want to use the over 2 wires column, and you always want to use area in square inches, okay? Area in square inches. So you want to follow this area in square inches down here, and you want to follow down to a number we just calculated. Now, the number we just calculated is 2.05. 2.05. Well, there's not going to be a 2.05, right? There never is, right? The exact number that you calculate. But if you just need 2.05 and you follow down here, 1.3 won't cut it, 1.8 won't cut it, but this one will. 2.9 won't it? Right? You see that 2.9? And then you follow it on over and you see a 3-inch, right? So what that means is that a 3-inch PVC, Schedule 40 PVC, can handle almost, well, 2.9, right? Almost 3 square inches area of conductors inside of it, right? So this can obviously handle the 2.0 that we came out with. So that would be the correct answer, trade size 3-inch, okay? Once again, we came up with 2.05. We're on the correct table. We slide down to 2.9 and then on over to size our 3 inches in this case. And let's go ahead and go back to the notepad, and let's right here use column for what's the title there? Make sure we get it. Over 2 wires in our notes. Over 2 wires, 40% fill. Okay, so that's the proper column, right? And we came up with a 3-inch PVC. Write that in your notes. That is the correct answer to that question. Okay, now that one was fairly easy. Time consuming, kind of slow, right? Took 7 or 8 minutes to solve. It's kind of slow, but notice it was the same size conductor, right? The same size conductor, being that it was all, in this case, if we go back to the question, we need to write this in our notes, by the way. Wasn't it all THHN? So let's just put that in there, right? They were all THHN, right? They're all the same insulation type, right? So we don't want to get that in our notes. Now, if they're different insulation types, then it gets to be a little bit, easier to make a mistake, because you're bouncing around from table to table, and it's just easier to make a mistake. So we should probably go ahead and do one of those and make sure we can handle if it's different size wire and different size insulation. So I think I have one prepped here that we can go over in this particular section of the lecture. So let's see down here. See, these are very similar type questions, right? It's 1 8-AUG and then 3 2-AUGs, but once again, THWN is the same, and we're using Schedule 40 PVC. This one here, same thing, THHN in this case, except for that's a little bit of a curveball. It's using liquid type, right? Type A, right? So you got to use the right table. Not hard, just find the right table, okay? But once again, same insulation. But this next one here, check it out. So let's go and work this one together and make sure we got this conduit sizing down, pinned to the wall here and down pat. Calculate the minimum size conduit for the following mixed, interesting, word there. THW and THHN conductors in the same raceway, right? And this time it's using what? Oh, well, Schedule 40 PVC, that's okay. Rigid Schedule 40 PVC. The number of conductors shall not exceed that permitted by the percentage fill in Table 1, Chapter 9. That sounds like fluff to me. Therefore, the installation would require what minimum trade size PVC? Okay, the installation. So, okay, so let's knock this one out, right? Let's get the math in here. If we got 4, let's go back to the notepad here. I want to clear this thing out. If you could clear it, get yourself a new page, that would be great. Or if it fits on the same page for you, then that's wonderful. Okay, but we do have 4 500 kc mil, and these particular conductors are insulated with THW. Okay, and so that's important, right? The insulation dictates the area of the conductor. Okay, they're thicker, thinner, whatever. And then there's also 4 different size and different insulation. This one's a 2-aught AUG, right? And a different insulation yet. So this one kind of throwing a little bit of a curveball at us here, right? Right? We got a different size wire and a different insulation type. So this we've got to just double, triple check, make sure we don't make a mistake. Not hard, just slow. Okay, so let's go ahead and do this together, make sure we got it right. Let's start with the THW since they're on top there. And table 5, we need to go back to table 5. So slide on down there until you find the THW. Okay, ours, again, it starts where it starts. Those are never on the exam. THW, yes, but those aren't big enough. So we got to go down to the second page of table 5, find RHW. Is it third page? Where'd it go? I must have passed it. We need THW. I'm sorry, THW. Is it in there? Oh, there it is. Okay, so hard to see, right? I'm actually on page 685, and I see my RHW right here. Okay, so I'm in the right section, and then I got to go down to, in this case, 500 kc mil. So I got to come way down here to 500 kc mil, and then come on over, and I see that 0.7 number. Okay. So that 0.7 number is pretty important, right? We got to write it down, and don't keep one finger in the code book and the other one writing down your decimal number, not to mess it up here. Remember that we are in area column for square inches, not diameter and not metric, and we landed up with 500 kc mil right there at the corner of the blue. There we see 0.7901. So that's what we need to put in our notes, right? So wouldn't it be, in this case, 4 conductors, right, times the number we just looked up, 0.7901, and that's going to give us some number, right? Let's not do the math yet. Let's go get these ones. How about we get these ones? 4 times the dimension, the area for these 2-aught AUGs, okay? So different insulation though, so be careful. Remember, the question was, now we're switching to THHN, so we can't just stay there. Now a lot of people mess up and just go right up to where the 2-aught are, and they would get this number, and that would of course be wrong. That would be the wrong number. You've got to go to the THHN section, which is down here. So a lot of people make that mistake. They stay up in the THW, get the other number, which would be wrong. Right here, I'm sorry. You got to switch sections to the THHN, right? Then you go down to the 2-aught AUG and come on over, okay? And then you find this 2223. It may not make a difference in this particular case, but it will, knowing these examinations nowadays, they're getting pretty tricky, okay? So that would be the correct decimal number for the area in square inches that we need to write down. So going back to our notepad, wouldn't it simply be 22.2223, right? And we just need to multiply these out, knock this one out of the park, right? Not too tough, just slow. take your time, 4 times 0.7901 on your calculator. So you should have come up with 3.16, right? 3.1604, right? That's, of course, inches squared, okay? Then the next one is to knock out this 4 times the 0.2223. So just pull up our calculator, 4 times 0.2223, and you get this number, 8892.8892. So I want to remember that. Close the calculator, and 0.8892 inches squared. Now these simply just add them up, right? You could just use basic math and add them manually, but I just prefer to, may as well just use the calculator, and that's how you could do it on their computer. They'll have a little calculator up in here in this area. You can just pop it down, use their calculator. Makes it pretty easy. So the 0.8892 is already in my calculator, so I'm just going to add the 3.1604 and hit the equals, and I get 4.04. So write that down, 4.0496 inches squared. Once again, this is our area, right, from table 5. We got to take this number on over to table 4 to size the PVC, right? Right. And in this case, I believe it was schedule 40. Let's just double check. Yes, it was schedule 40 right there. It says so in our notepad. Let's just go ahead and put PVC schedule 40. Okay, so let's go ahead and do that. Wrap this thing up. Just slide on up, right? Table 5 is kind of long, not real long, but it's long enough that you can make a mistake. Just be careful. And want to go to PVC once again, this rigid type A and all this stuff. There's schedule 40 right there, right? There's schedule 40 right there. We want to make sure we go over 2 R's, 40% fill, right? Come on down till we see the 404, right? And 3.5 inches won't cut it, right? That's 3.8. Wouldn't we have to go down to the 5 inch squared and come on over and get a 4 inch? Okay, so let's go ahead and put that in our notes, right? We'll go in this direction, right? A trade size 4 inch. Schedule 40 PVC. Put a box around that, and we're done with that question. So once again, on this conduit fill issue, as we mentioned before, we want to make sure that we either use Annex C, right? If it's the same size. If it's the same size wires, super easy, right? Let's even put there easy, because it is. We use Annex C, right? But if it's different, wires, not so easy, right? It's kind of slow. Let's put slow in there, right? Slow. We got to use chapter 9, table 5, then table 4, okay? On the test, for sure, without a question, you got to know how to do that one, okay? So, I mean, there's other ones in there, regarding the math, right? Aside from conduit fill. So I'd kind of like to move off conduit fill here. We've been talking about it for a while. See if we can't talk about another subject, okay? But conduit fill, they're really beefing up the test with that type of questions. Just a lot of tedious looking things up, okay? But here's another one. National Electrical Code ground electrical conductor requirements include that each plate electrode electrically conductor coated iron or steel plates shall expose not less than how many inches, of surface to the exterior buried underground soil? Okay, kind of a weird question. It's really more of a code reference than math or calculations, but let's just go ahead and go there, make sure we know, how they came up with their answer. Not much of a calculation, but still, it could be on the what they would consider a calculations portion of the exam. Okay, so 25052A7, let's go and turn there in our code books. Getting off conduit field, I thought that was pretty good. Hope we got all that. Okay, no, but 25052 is ground electrodes. Ground electrodes. Okay, so moving on to grounding electrodes. We'll be doing ground electrodes and equipment grounds, later on in the lecture as well. It's important that we can do these because they're pretty doggone easy. Okay, now this particular question is in section A7 of that chapter. So there's A, then we've got to go down to 2, 3, got to go all the way down to 7. There's 4, 5, 6, 7. So plate electrodes. Okay, so that's where we're at in the code book right there. Plate electrodes. I'm actually on page 113. Okay, and notice there that it says each plate electrode shall expose not less than 2 square feet of surface to exterior soil. Very easy question. I mean, but this testing agency, they don't. One of the multiple choice is not 2 square feet. It should, one of the answers should just be 2 square feet, right? But they go and word it all crazy and put it in square inches. Okay, so you need to convert that, right? Not too tough to do, right? So let's just go ahead and put that thing a little fit in, the page that I'm working on here. But let's go ahead and clear it out, and that way, we got a fresh slate here because we moved off a conduit fill. Let's just clear that one out of there and do another one here. So once again, so that we don't forget where we're at, right? We're on plate electrodes. You should put this in your notes. Electrodes, right? They have a question off of here, and it's on section 250.52A7. Okay, so get that in your notes. Okay, that's an A, by the way, A7. Okay. Okay, and so it said 2 square feet, right? That's what it said, but that's not the answer. One of the answers, because the answers are in square inches, right? The answers are in square inches. Well, isn't 1 foot equal to 12 inches, right? Right, 12 inches, right? 1 foot is equal to 12 inches. Right? In area, we know is equal to the length times the width. We all know that, right? So 12 inches of length times 12 inches of width is equal to 144 inches squared, right? But remember, that's only for 1 foot, right? So wouldn't we simply get the 144 inch squared times 2, and that equals 288 inches squared. And we knocked it out of the park. Okay, make sure you highlight that. Put a box around it in your notes. Okay. Boy, there's just a ton of math all over the place here. Not tough. Some of them are pretty easy. Let's see if we can knock a couple out here. At least one more here. Let's go ahead and do this one here. This one is on voltage drop, but it's not really that tricky of a question. It is on fire pumps, and that's something that I do want for you to review. And we talked about that earlier. As a matter of fact, I think I have a document here. I'm just going to flash it up here real quick. That way y'all can see it, because want to make sure that we, don't forget, that this is our homework, right? This is our homework right here. Let's see if I can get this a little bit bigger. View. Let's go with text width. Okay, so very important here. Temporary installations, 590. Electric vehicle charging system, 625. Solar or photovoltaic system, 690, and then fire pumps, 695. They're just hitting these questions quite a bit, you guys. Want to make sure I flashed it up here one more time and make sure that we get this. read and studied in our code books, right? Once again, Article 590, 625, 690, and 695 are showing up quite a bit on the examination. Okay, so that's just a quick review. Here's one of the questions, right? The starting and running voltage drop of a fire pump must be limited to using a minimum conductor rated at how many amperes? Okay, so how many amps, considering that the pump and its associated loads draw 120 during normal operation? Okay, well, it's going to be pretty easy actually, right? If we know what the load is, and there's a code reference here. Let's go and turn there for fire pumps. 695, if you haven't already read this, and maybe you've never even seen it in the code book, 695 is a section in there for fire pumps. So let's go and turn there, 695, in this case 695.6, and right in this area here, you see the power, right? And we actually want B. Section B is up here at the top, conductor size, and then 1, right, gives us our 125%. So you might want to box that little paragraph there, and then with your pen, just go ahead and circle, you know, that 125%. It's buried right in there in the middle. Okay, 125%. Okay, is pretty typical. Okay, and we need to make sure we make that multiplier. We'll get the answer wrong. And so very simply here, if we look back at the question, as a matter of fact, we should go ahead and write this in our notes, right? Let's just put a line here because we finished that one up. It was just a code reference with a simple calculation. But this one here on fire pumps, so let's put it in our notes, fire pump question, right? And we were on 695.6. B1 is where we found our 125% multiplier. Okay, that's pretty typical, right? It's something we should be able to kind of like remember, okay, during the examination, just kind of default there. Okay, there'll be a lot of exceptions, okay, but in general, that's a pretty good guess, okay, if you had to guess. But we really don't guess around here. We look it up, find the code reference, say, ah, there it is, because it could be 115, it could be 175. Who knows, right? We got to find it, look it up. In this case, 125%, right? So in the load, it said that the load was a current draw of 120 amps. Okay, so if we have a load of 120 amps, right, and we multiply that by 1.25, right, and then get our calculator out and just knock this thing out, right? 120 times 1.25, and you get 150, right? So 150 amps, put a box around that, put a star on it, right? And that would be the answer to this question. Right, considering that the pump and its associated load draws 120 during normal operation, right? What would be the minimum conductor? How many amps? Right? Well, you know, you just can't have, if it's going to be drawing 120, the conductors have to be rated to hold 150. I mean, that should make sense. You shouldn't go the other way. That would be kind of naive, right? So 150 amps in this case. And I appreciate your time. Thank you.